Hello everyone, welcome to our monthly webinar discovery series. These are interactive sessions happen once in a month and we take one topic. Topic for this month was understanding the big why behind MPLS. This was an interactive series and here this is the recorded version of the same session. From the agenda perspective, what we will be looking at is first, let's just understand the big why behind MPLS. Why MPLS was needed in the first place. What were the problem that the industry was trying to solve with MPLS? Then, depending on the interactive discussions, I added few more items to this recorded version. One of them is why it got so much popular, and was the label based forwarding was the only reason behind that, or there was something else to it. And then the third item is, if it was so good, then why there are limited traces or deployment in other domains, for example data center or enterprises. So we will discover these two aspects as well in this session. This webinar is meant for the beginners, but even the experienced user will find some information which is valuable or useful for them. So feel free to watch at 1.5 or 2x speed and slow down wherever you need. Before we get into this, my name is Sunil Pareek, and if you want to join such interactive webinars, check the description box for this video. So now let us start with exactly what is MPLS. And when I first encountered MPLS, I remember during my school days, my principal, sir, whom I still respect a lot, always used to challenge us to come up with some efficient way of whatever we were doing in the school. He used to give us some task. And in one such occasion, I still remember that there was a prize distribution ceremony where close to 50 students were supposed to get the prize. So principal sir called us being in a higher grade and he said that come up with some method so that he can distribute these prizes to the deserving students which were across different grades. So what we did is we took the list from the sir for all the student names and we just put a name tag on each of the gift. And then when our sir came in, it was the time to distribute the prizes. So he looked at it and then he was looking the name and then he was giving it to the student, and it was taking time and we could see that he was not that happy. So next time when the similar event come, he asked us that this time the same event will happen, but for the higher grade student, number of students are more or less same. So come up with a better way this time. So considering the learnings that we had, what we did this time is we simply put some sort of labels, a color coded labels rather than the name on the prizes which were meant for different grades. And when our sir walked in, It was very easy just by looking at that colored label. Let's say red means the price for the 7th graders, green means the price for the 8th graders. So it was very fast for him to just pick it up, the green color, and give it to a 8th class student. And he was very happy by looking at this way. This was the same impression I got when I first set to learn MPLS. It was back in 2007 when we were starting doing some migration from frame relay to MPLS, and that's when my first encounter happened with MPLS. Of course, at that time there were limited resources in terms of learning, and we faced many issues also. And I still remember in our department we used to call MPLS as most painful learning for SPs. But very soon it became from painful to most pleasant learning for SPs. So, why it transitioned from painful to pleasant is what we will cover in this webinar. So, if you are excited, then let's continue. Let's just look at the historical perspective where work started on MPLS in IETF somewhere around 1997, and multi-protocol label switching, that's actually MPLS stands for. It was not most painful or most pleasant learning. It was actually, or it is actually, more multi-protocol label switching, and it has very soon evolved from exotic technology to a mainstream solution. Rapid deployments for some of its application. We will see that in our session today in few minutes from now. But do you guys know when was the first customer deployed MPLS? Or when the first customer deployed these MPLS based VPN services? It was actually in 1999. So now let us look at some of the original MPLS problem statements that were there on the table for this working group. And from here, we will see how MPLS was solving it, and soon it became a solution adopted by almost all the SPs in the world. So the first problem statement was scalability of network layer routing. So this was the time when one term was getting popular, which was VPN, virtual private networks. And providers were looking for an efficient way of deploying this. So what were the ways to deploy a VPN? I will cover a few of them. So one of them could be, let's just take an example of simply 3 routers, and let me create a VLAN based network. So I just create VLAN 10 here, VLAN 10 here also, and here. And then my endpoint, let's say E1 and E2, can talk to each other. Soon there was a requirement from the different customer to have another set of VLANs. So what we did is we created another VLAN, let's say 11 on all these nodes, and same way provided a communication for these green endpoints. After certain time, there was an ask from the customer that VLAN, okay, it was providing some layer 2 based isolation. Can we do something with layer 3? So let's just take the same example of 3 nodes, but this time what was done is we configured a VRF. Let's say VRF A here, VRF A here, VRF A here, and then my E1 was talking to E2 even though they were in a different subnet. Same way it can happen for the green endpoint as well, for which the BRF is B, let's say, or green. So this was the second way. And then there was a third way which was proposed, and that's, let's understand with the same example. I have my same 3 node, and here I implement, let's say, VRF A. All these 3 nodes are connected, and then I made some sort of tunnel and configure the VRF A here, and now also my E2 can talk to E1, and same methodology go for green VRF also, which is VRF B, VRF B, and then you have some sort of tunnel created, and your E1 and E2 can talk to each other. Now think for a minute, what is the fundamental difference that you see in these 3? The first 2, even though they were providing some sort of VPN, but you need to create on each hop. But here in the third approach, you are creating the VPN, but this intermediate node is completely unaware of it. So today there are only 2, tomorrow there could be 100 or thousands. These intermediate nodes are not even bothered about it. Whereas in these 2, at certain point you will definitely hit the scale limitation. This is the example of L3VPN, and this is called as overlay networking. Overlay networking we will touch base again in our session, but even if you don't understand what L3VPN is or whatever, but by looking at this analogy where you configure VPNs only on the egress node, there could be thousands of nodes in between. They are not even aware of it. And another important point is, let's say there is an egress node here where I have only red network or VRF A, let's say. Then this node doesn't even need VRF green. So clearly a scalable way. And that's why L3VPN is one of the most deployed solution for service providers. I can challenge you to find a single SP, single service provider, T1, Tier 2, Tier 3, Tier 4. They are all using L3VPNs. So this way, MPLS or MPLS based application helped to achieve the scale, where we use the label to aggregate forwardings, right? How basically this work? So let's take that L3VPN example only. So there will be this tunnel, a virtual tunnel that will be created. Let's say here is my E2 and here is my E1, which are endpoint. And then this guy will supply a label directly to the ingress node. Let's say this is our ingress, this is our egress. And when the packet come, whatever the packet come, I will simply encapsulate that packet with this label and send it in this direction. And when it reaches here, we will take off this label and forward it. I have highly simplified this. If you understand L3VPN, well and good. If you don't, then also it's okay. We will look at this forwarding in much more detail. But for now, you just understand that MPLS with the help of L3VPN or same goes on L2VPN also provided a scalable way for routing. And that's what the SPs are looking for. They wanted to serve thousands of customers. So this was the first reason for MPLS getting so popular. And it was not exactly MPLS, it was MPLS enabled application, which is L3VPN or L2VPN. The next set of problem was some sort of flexibility in delivering routing services. Let me use an analogy here. Let's say that you want to travel from point A to point B. You have taken a bike, and then let's say this is the direct route, but somebody just tell you that there is a heavy traffic here already between this stretch. This is very normal in the city of Bangalore, or maybe even for other bigger cities as well. So there is a detour, let's say, which just beat at this point and you can directly reach P. But this is the shortest path. The path that I have drawn in solid is the shortest path. So your routing protocol, if you think from that perspective, will always take this path even though it is congested. But since we have heavy traffic here, can we have some sort of algorithm which can direct the traffic from A to B on this path? And that is what the traffic engineering in MPLS is. MPLS traffic engineering exactly does this. What they have is they have some sort of CSPF. What CSPF is, it's a variation of shortest path first, but a constrained shortest path first. What I mean by that? It means that it puts some sort of constraints that, okay, there is some heavy traffic, so don't consider this solid link. Come up with some alternate path, right? So with SPF, it also carries some constraints. Don't go from this path, even though you will reach your destination, but it will take time. So you take another path. So you can specify your criteria that okay, I want a path with these things. CSPF take all these constraints into the picture and then calculate a shortest path meeting or try to meet all those constraints. So, using labels to identify a particular traffic type which receives some sort of special treatment. Here, A to B, we want to reach faster. But if we take this path, we will get stuck in traffic. So, we took this dotted path. You can call it quality of service also, where you can send the traffic on different path depending on what quality of service they have signed up for. For example, you can plan this traffic distribution well where the traffic with low latency, let's say, or voice traffic, for example, can go on directly on this path, whereas the other traffic, let's say high bandwidth traffic, can go via this path. So this is the flexibility that MPLS provided. So another MPLS application which was very useful for the providers. So this was the second reason. The third reason is increased performance. And what basically people think here that the label swapping paradigm is much faster, and that's how MPLS achieve greater performance results. But in the time when the routers are so powerful, right, even IP based forwarding can happen in ASICs, and it can be as fast as the routers which is MPLS based packets. So many people get this wrong. This was not exactly the reason. The exact reason was in the wider picture, which I just described, where you can divert your traffic depending on the need, and that too via efficient ways. For example, in these two nodes, let's say I have a network like this, right? So let's say this is path number 1, this is path number 2, and this is path number 3. From A to B, I have 3 paths, but I will always take path number 1 if I just go with IGP. Or if I just tune the metric, get into that complex way to tune in some IGP metric, then it can even utilize path number 2 or 3. But again, that is not a scalable way. But if I have some sort of TE tunnels created via this path, let's say 3 tunnels, I can efficiently distribute the traffic and meet required performance numbers which are being asked by my customers. So this is the third problem statement, and MPLS addressed it with its applications. By now, did you guys saw one pattern in whatever I was talking so far? Whenever I have emphasized on MPLS usefulness, I have talked about its applications. be it L3 VPN or traffic engineering, right? Not just the label based forwarding. And this is what you need to understand from this webinar also. It is the applications of MPLS which made it so popular rather than just the label based forwarding. This is the key message for this webinar. If you understand this, the purpose of this webinar is achieved. Now let's just look at some more problems. The fourth statement that this group was having is simplify the integration of router with cell switching based technologies. If you are somebody who didn't even understood it, you are not alone, and you know you don't even need to understand this. It's not of much relevance as of now. It was there in the time of ATMs or legacy frame relay network, as I was talking earlier, but now you don't need to invest time in learning these because they are not there on a wider scale anymore. But then why in the first place I had shown you this? There was a reason. The reason was that SP liked L3VPN or TEs, all these applications very much, that they wanted to have everything on MPLS. Basically your Sonnet, SDH, all that layer 1 stuff, can that be taken over MPLS? And that's how GMPLS was born. So for now, you just understand that provider liked it so much that they wanted to take everything, whatever services they were providing, be it PSTN, be it Sonnet, SGT, whatever, layer 1 services, layer 2 services, or even layer 3 services as per OSI model, they wanted to have it on MPLS. Don't worry if you don't understand what GMPLS is, what Sonnet is, what SDH is. Just understand this, that this is what SPs were looking for. So for now, I have talked about L3VPN, an efficient way of overlay networking. You may be wondering what overlay is, or some of the beginners who are watching this webinar may be wondering what an overlay is. So now let's just shift our focus from these problem statements, and we have visited 4 by the way, and originally on the draft or this working group there were only 4 problems that we have visited were there on the table. Now let's just shift our focus on overlay, and then we will try to answer some of the other agenda items that we discussed initially. So what exactly an overlay is? So I'm highly simplifying this. Let's say for the beginners, what an underlay and overlay concept is. Let's say you go to your college or office. You must be using some road like this, and you travel in a car and go to your office. There is another person or your neighbor who want to do some cycling because he want to keep himself fit, uses the same road and go to a park. Here, think for a minute that it is the same road. You are using it to go to your office, your neighbor is using it to go to the park. The underlay is same. It is this road, and you act like a overlay here where you are going to office, your neighbor is going to the park. Same way, in the networking, this is your road, let's say, or this is your physical infrastructure. On top of this, you implement some sort of overlay network for customer one, let's say, or tenant one, which is running completely different services, and then you implement another overlay for a different customer which run completely different set of services, right? So this decoupling from underlay to overlay simplifies a lot of things and is a very efficient way to achieve segmentation, scale, and one of the famous term that you might have heard in data center is multi-tenants. My customer one is one tenant, customer two is another tenant. And to achieve this overlay, networking has been bombarded, and I repeat, networking has been bombarded with so many overlays. As you see here, GRE, L3VPN we just discussed, L2VPN, SD access, EVPN, and the list just goes on. There are so many of these overlays that exist. During the start of this session, I talked about L3VPN, right? And I briefly explained you the forwarding of that. So before we get into our second agenda item, like why MPLS was not that successful in data center or enterprises, we will primarily talk about data center, considering the time for this webinar. But before that, let's just consider or understand what an overlay network forwarding is. So in any overlay, I had shown you many examples, or even L3VPN. What I'm going to explain you, the fundamental thing doesn't change. So let's say there is a packet which go from CE1 to CE2 in this direction. So this is customer and this is my provider network. CE1 at location 1, CE2 can be another location, and they want to communicate over a VPN or overlay, let's say. What will happen? This R1 here that you see will take this entire packet, and I repeat, will take this entire packet and encapsulate it in a completely different new packet. And in this domain, this SP domain, or you can call it any overlay network or even DC fabric, let's say data center fabric, forwarding happen based on this outer packet only. So R2 will simply look at R3 and will send this packet in this direction. And then when R3 is sending it, because R3 is the final destination, so R3 will remove these two packets, this outer packet, and send this original packet that you see here towards CA2. That is how your forwarding work in any overlay network. Since we are talking about L3 VPN, these R1 and R3 are actually the labels here. One of them is VPN v4 label, another one is transport label. I am highly simplifying this just because of the time constraint here, but this is for the beginners that in any overlay network, we simply encapsulate the packet and then send it. That encapsulated packet can be a labeled packet also in case of L3 VPN. Right? So now let's understand this. Did MPLS only rule SP network, or was there some deployments in data center also? So as I was saying, overlay rules our networking world. MPLS, L3VPN, L2VPN, SDXS, ACI, EVPN, GRE. There are so many of these overlay networks. So the obvious question can be, which overlay is good for my network? Right? As we had seen during our start, overlays solve a big connectivity problem. It provides a scalable way. We had seen it for L3VPN right at the start, right? L3VPN is one of the scalable way of provisioning VPN, and at the same time it provides segmentation as well. Right? So why can't this L3 VPN can be a choice for even data center or cloud also? But as we say, there is no one right way, there is actually your right way. This is a very famous saying in networking where we say it depends. Basically, we need to understand the requirement and then a suitable design can be proposed. So during our discussion with customer, whenever we talked about MPLS in the data center or cloud, some of the factors which work in favor, some of the factors which are against, I will put those in front of you, and that should give you some indication why MPLS didn't fly well in the DC market, and there was another solution called VXLAN. Right? So let's just first look at some of the favors or the pros for MPLS. MPLS was already there in the WAN. It was scalable. It was already tested solution by SPs. Right? It provide multiple tenancy for SPs, the segmentation for SP, VPN1, VPN2. Right? So same way it can provide the same thing for data center as well. But then there were few factors which were against it, that DC teams were not that familiar with MPLS. That's what our customer also tell us, that we don't understand MPLS at that depth. It is primarily a SP solution. The second thing is, in the underlay, as we talked about overlay and underlay, if there is a MPLS, then underlay has to support MPLS, which was not the popular case with data centers. They just wanted to have some sort of IP overlay only, and that's why VXLAN got popular. And if you recall, I said and I repeat that again, it was not MPLS. It was MPLS enabled applications which the providers found very useful, and that was the key ingredient behind its popularity. But data centers, they said that we need multi-tenancy, we need segmentation for sure, but we don't need traffic engineering. So they clearly denied one of the very famous, widely deployed application of MPLS, and it doesn't mean any sense to them also, because data center in a fabric, there is no bandwidth crunch as such. In the leaf spine architecture, there is no bandwidth crunch. In fact, we used to joke about it that in the fabric the bandwidth is infinite, so why you need to go into the complexity of traffic engineering. So these were few of the reasons for not getting into the MPLS deployment for data centers. I hope this makes sense. And now that we are talking about MPLS, let's just understand a bit of it. How does MPLS forwarding works? For the advanced users, you are more than welcome to stop the session here because we cover our main agenda items. This is for the very basic beginners who want to understand MPLS forwarding, and I will give a glimpse of it basically. So for this analogy, let's just forget the CE2 or CE1. Let's just say that I have these 4 nodes and I want MPLS based forward. First of all, there are 3 protocols: LDP, RSVP, and BGP. Because MPLS forward packet based on labels, so these are the 3 protocols which supplied labels, in a dynamic way. Of course, they have different applications. For example, RSVP you only use when you need traffic engineering, and now we are already moving towards segment routing, but that's a different topic, so let's just not go there. Right? Let's just take LDP as an example. So LDP is enabled on all these devices, on all these interfaces. At a high level, let's say I have a loopback here which is 4.4.4.4. What LDP do is it allocate one label to all the directly connected interfaces of PE4, and then it distribute that or send towards P3. Again, I am highly simplifying this here. So 4.4.4, let's say it allocates some label as 10. Again, this is for the analogy. There are some efficient way like implicit null and all. We are not going there. Let's say it simply allocated label 10 here. That 10 will be received, let's say, on this interface. Now P3, because we are running LDP, let's say, along with OSPF. So P3 will learn this route via OSPF, and P3 LDP protocol, because you are running LDP here also, will allocate, let's say, another label which is 11, for example. This 11 will be sent here, and then this guy will allocate, let's say, a label 15 that will be sent in this direction. So when somebody want to send a packet, and the destination is 4.4.4.4, what PE1 will do? PE1 will simply put a label 15 on this one and send the packet in this direction. Now listen to me carefully here. P2 will look at this incoming label only 15, and it will simply swap that label with 11. It will not look at this internal destination, what exactly that is. It will simply swap this operation. So here swap will happen. Then you send the packet in this direction towards P3. What P3 will do, you might have guessed by now, it will replace 11 with 10. And then the packet will send in this direction. Here, it will see that 10 is allocated to 4.4.4 and it will forward this packet to that loop back. And you get a response. Again, as I was saying, I'm not going into that PHP or implicit, explicit, null stuff. It's a simple label based forwarding that you see here. We will have some more webinars covering much more detail, but for now, let's just conclude this. I hope you at least got some glimpse of MPLS based forwarding, and with this webinar you also understood why we needed MPLS, then why it got so much popular, and again I reiterate before you leave this session, it was MPLS based applications like L3VPN, L2VPN or TEs, right? That made it so popular. Then we looked at why it did not get that much success in the data center world, followed by some basic MPLS forwarding. I hope the session was informative for you, and thanks a lot for viewing. In case you want to sign up for interactive webinars, as I said at the start, look at the link in the description box to join the group. Thank you.